Suppose that the functions f and g are defined as follows. So we have f of x is equal to x minus 5 times x plus 2, and g of x is equal to 5x plus 4. Now, part A is asking us to find the quotient g divided by f at x equals -2. And then part B is asking us to find all the values that are not in the domain of this quotient. So here we go. Part A. Part A again is asking us to find the quotient g by f of -1. And so applying the quotient definition here, we can rewrite this as g of -1 divided by f of -1. So let's step to the side real quick and find these functions' evaluations at -1. So we have g of -1 is going to be equal to 5 multiplied by -1 plus 4. So that's -5 plus 4, which leaves us with -1. And very similarly, we want to evaluate the function f when x is -1. So this is going to become -1 minus 5 multiplied by -1 plus 2. So simplifying this is -6 multiplied by 1, which leaves us with a beautiful final answer of -6. So let's take these now and plug them into the quotient. So we can say that therefore g of -1 divided by f of -1 is equal to -1 divided by -6, and we see a negative divided by a negative, we know that becomes a positive. So we are left with a beautiful final answer of 1/6. Now, in part B, we're going to be working with the same functions, but this time we're looking for the values that are not in the domain. So part B, the first thing that we need to come up with is the function for this quotient g by f of x. So expanding this out, we know that this implies that this is equal to g of x over f of x, and this is going to be such that f of x cannot be equal to 0, because we know that division by 0 is undefined. So let's plug these functions in. We can say that this is equal to, we have 5x plus 4 in the numerator, and this is all divided by x minus 5 times x plus 2. Now this again is such that this denominator can't be equal to 0. So let's actually rewrite this down here. So this is going to be such that this denominator, x minus 5 multiplied by x plus 2, cannot be equal to 0. So we have two cases to solve for here. We want to think about the case when x minus 5 cannot be equal to 0. And we also need to think about the case when x plus 2 is not equal to 0. So in case 1, we can solve for x here by adding 5 to both sides of the expression. So minus 5 plus 5 cancels itself out to 0. And we see that x cannot be equal to 5. And in case 2, if we subtract 2 from both sides of our expression, we can see plus 2 minus 2 cancels to 0, showing us that x cannot be equal to -2. So these are the values that we need to exclude from our domain. We can say that therefore x can be any real number. So any real number our little hearts desire, except +5 and -2. And so this is our beautiful final answer to part B.